Okay, so I'm going to conclude this chapter for now with this nice long table from the book which summarizes the climatic events and their global distribution along with effects on agriculture, just to bring together the various ideas we've been discussing. And these are based on the books Brooks, Diamond, Fagan, and Levine. So I have a couple of these books, and depending on whether they add more information with nice figures, I may add more podcasts to this a little bit later on after concluding the next chapter. Okay, so I have to read through the books before deciding whether something more is worth adding. Okay, so let's start again at the tail end of the last glacial maximum, 12,000 years to 10,000 years ago, and climatic event, type of climatic event and effect on agriculture and civilization. I will read through them just so that we remind ourselves the details of what we've been talking about. Lake Agassiz, meltwater spill, Younger Dryas, cooling and drying. We have talked about this, about the melting of glaciers coming out of the last glacial maximum was dammed by a glacier that didn't melt over Lake Agassiz, and meltwater apparently spilled onto the North Atlantic, where the deepwater formation was heavily perturbed and meridional overturning circulation was reduced. Northward heat transport was reduced, leading to refreezing, which a surprising thing is how quickly and rapidly it happened and how widespread the impacts were. So effect on agriculture and civilization: domestication of dog, herding of sheep and goats in the Fertile Crescent, incipient cereal culture, populations concentrated in refugia. The concept of refugia is really important, even though we didn't cover all the typographies of how they get formed, but you should have a good idea that these do get formed based on mountain, valleys, coasts, forests, and so on. Crop culture in the Americas and China. 8,200 years ago, the Laurentide meltwater spill. Remember, Laurentide ice sheet is what covered North America and parts of Europe. Cooling and drying in the northern hemisphere. Advancement of farming around Euxine Lake, Black Sea. Emigration of farmers, complexification of Chinese settlements around major rivers. So we begin to talk about societies and their responses, either in response to rich, wet agricultural productive periods, or driven by trades between two cultures to find resources that they don't have, and so on and so forth. 7,800 years ago, the expansion of monsoon regions, spread of farming with more sophisticated tools. 7,000 years ago, consistent higher frequency of ENSO events, drying of North African lakes. Increased social stratification happened, better irrigation techniques in the Fertile Crescent emerged. So 6,000 years ago, there was a decrease in solar insolation that began. Rise of cattle cults that we looked at with tables, and current responses from India and Tanzania and how they could help interpret past cattle cults. Badarian cattle herders settle on the west bank of Nile. Rise of Sumer, specialization of military organization. So that is associated potentially with the beginning of the drying trend with the solar insolation, so end of African green period, and so on and so forth. 5,500 to 4,900 years ago, peak in ENSO events. As I said before, this idea of ENSO variability through the Holocene has been written in multiple papers, and there is a bit of debate about exactly how widespread or how statistically significant these changes are. Okay, whether there was in fact changes, because based on where the evidence came from, which island, and where the seasonal variability may be confused with ENSO variability because of the low frequency of the records and so on, add to the complexities of how to interpret ENSO changes during the Holocene. Increased dependency on irrigation and occupation of Caral in Peru was a result. Of course, the South American regions get very directly affected by ENSO, especially Peru, Ecuador, Chile, and so on. 4,200 years ago, 300-year drought in Mesopotamia, which also had an impact on the Mohenjo-daro Harappa culture. Changes in major crops in Europe, 3,100 years ago. Eruption of Hekla, cooling and drying, so volcanic eruption. Extermination of Icelandic farming, intensification of deforestation for farming and timber constructions. 3,000 years ago, extreme drying in China. Migration of Mongols to Hungarian plain, horse cultures expand into Europe. 2,300 years ago, migration of Mediterranean ecotone to central Gaul. So the Mediterranean weather, which is characterized by the semi-arid kind of ecotone, migrated. Again, remembering that ecosystems generally don't move. Some species which are more adaptable to climate move, and the others that are sedentary end up going extinct. So the ecotones change and move. Extension of benign climate increase in Roman influence in Europe. Okay, so 2485 to 2060 years ago, droughts related to ENSO shifts, early Maya settlements, local growth of agriculture. 2000 years ago, eruption of Popocatépetl. I had trouble with this before. So the crash of Mesoamerican cities, possibly linked with top-heavy social changes in pre-eruptive period and so events. So societal structure may have been less resilient because of the changes that had happened before. Top-heavy meaning the working population was dominated by the social changes at the top, who were basically ruling and not really innovating to survive the sudden abrupt changes introduced by eruption of a volcano. 2135 to 1830 years ago, droughts related to ENSO shift, survival of cities with irrigation. So this shows how innovation and investment in irrigation implementations would have allowed better survival through droughts and ENSO shifts. 1260 to 985 years ago, final drought that lowered the Mayan water table, collapse of Maya cities, and arable areas got desertified. Coming closer, type of climatic event effect on agriculture and civilization at 1500 years ago. A supervolcano eruption or a comet impact produced a 7-year cold period. So southeastward migration of the Mongols, 1100 to 700 years ago. ENSO events, medieval warm period, southern migration of the Mediterranean ecotones. Decrease in soil quality affected agriculture, and there was use of heavier agricultural tools. Eastward migration of European farmers increased deforestation. So population increase would have been already manifest by this time, and the Vikings were there on Greenland doing agriculture. 700 years ago, much closer to the present, cooling associated with the Little Ice Age began. Crop yields diminished by cooling and drying, and widespread starvation. You can Google Little Ice Age and you will get lots of historic documents, evidences, paintings that show Netherlands iced over and people moving on ice with what looked like skates and so on and so forth. 195 years ago, eruption of Mount Tambora, year without a summer, widespread crop failures. There are many stories associated with that, but the cooling was probably order 0.5 degrees, and this is definitely recorded well in terms of impacts on crops and so on. 160 years ago, gradual warming period until present time, global warming from industrial revolution, well, question mark is left here, but by now we have talked about how we can track CO2 emissions and also look at isotopic compositions of atmospheric CO2 to identify sources as being fossil fuel, and we know the physics of how increased CO2 levels trap radiation and produce the warming. So that's their detectable beyond natural variability. So we haven't talked about detection and attribution here, but when you detect a trend, then you have to go back and attribute it to causes, and we do that with the techniques and model use and so on. Agricultural revolutions, more selective breeding of plants and animals, improved survival over wintering cattle and so on. And by now, beyond 160 years ago to the present, agriculture has become a super industrialized, super mechanized. Now we are into smart agriculture, instruments, satellite data, climate predictions, genetically modified crops, and so on. And of course, population has grown super exponentially as well. And UN just put out a report that will be hitting 8 billion very soon. And then we also talked about dropping fertility rates and so on. So we'll look at all those sorts of human interactions and future of humanity in the next chapter to conclude this series of podcasts on climate and human evolution. For now, I will leave this chapter here, and then, as I said, I'll add some stuff from books by Fagan and Brooks, if relevant. Okay.